In this next example, we're going to be looking for 3 answers instead of just 2 like we have in the previous ones. And the reason for that is that if we were to FOIL this out, to multiply this out, do you see that x times the 4x squared would give us an x to the 3rd power? So we call this polynomial a polynomial of degree 3, which means it can have up to 3 answers. So this part, the x plus 3, already is a factor, so we're just going to bring it along for the ride and work with factoring this until it is just linear pieces, only a degree of x to the 1st, so that we can set each section equal to 0. So if you notice, looking at this 4x squared minus 11x minus 3, that quadratic that's on the inside is actually exactly the same quadratic that we got up here when we multiplied out this example number 1. So I don't even really have to go through all of these steps again. I'm just going to show you what we do when we get to the next part. So you'd follow the same process here of multiplying 4 times negative 3, getting the negative 12, asking yourself what factors of negative 12 would add to negative 11, and those are a negative 12 and a 1, which is how that would break up into a negative 12x plus 1x. Then we factor those 2 pieces by grouping until we eventually end up here. So I'm going to go ahead and start right there at that step, where we have the x plus 3 that we carried along from our original problem. We also have a 4x plus 1, and we have an x minus 3. So that's the factored form of that problem. Then we set each one of those pieces equal to 0. The x plus 3 equal to 0 is going to give us an x equals negative 3. The 4x plus 1 equal to 0 is going to give us an x equals negative 1/4. And the x minus 3 equal to 0 is going to give us an x equals positive 3. So any one of those 3 solutions would work as a solution to that equation. Going on to our final example is going to deal with some pretty big numbers here. We have an x to the 3rd power, which means we can expect 3 answers from this question, and each one of our terms has a greatest common factor of x. So I'm going to go ahead and take that GCF of x out first. So I have an x on the outside, nice big bracket with a 36x squared plus x minus 21 on the inside. Using Stephanie's method, I multiply 36 by negative 21, and it gives me a negative 756, which I did not do in my head. Figured that out on a calculator ahead of time. And then I look at what are the possible factors of 756. Well, this is where understanding how factors work might help you. I know I'm trying to get to a difference of just 1. So of all the possible factors that would make 756, 1 times 756 is going to have a difference of 755, so that's not going to work. And even the 36 and the 21 that I started with, and the negative 21 I guess it was, still have a difference of 15. So I'm looking for factors of 756 that are going to be really close together. So that sends me to look at, well, what are the pieces that made up this 36? And 36 is 6 times 6, or 2 times 2 times 3 times 3. And the 21 is made up of a 3 times 7. So I'm trying to figure out, is there a way that I can group this collection of 2 2s and 3 3s in a 7 in a way that they're going to come out to be numbers that are really close together. So if I put the 3 3's together, 3 times 3 times 3 is going to give me 27, and 2 times 2 times 7 is going to give me 28. So that 27 times 28 is the magical group of factors that when I make this one negative, because I want that to come out to be a positive, I get a difference of 1. So usually you're only going to see the chart filled out like this, as if it's something that everybody knows, because everybody knows their 756 times tables, but that's really not the case. Sometimes it takes some more thinking than just knowing the factors in your head like you did for this one or for this one, and knowing how to factor those numbers into smaller pieces and thinking of ways that you could combine those pieces to get them to numbers that are really close to each other is a skill you're going to need. So come talk to me about that if you want to see more on that. So now knowing that this is our two pieces we're going to break it into, we're going to leave that x on the outside, copy the 36x squared and the minus 21 and the equals 0. All of that is staying the same, and then I am breaking down this middle x into two really big terms here, a minus 27x and a plus 28x. So it seems like a kind of funny way to divide up x, but that's what's going to give me, by grouping, the ability to take a 9 and an x out of this first term, leaving me with 4x minus 3, and out of the second term, a 7, which will also leave me with a 4x minus 3. Since these two binomials match, I can factor those out and leave myself with the 9x plus 7. So my final groupings for this are an x, a 9x plus 7, and a 4x minus 3 is what equals 0. Then looking at each one of those individual factors set equal to 0, I'm going to get x equals 0, x equals a negative 7/9, or x equals 3/4. And that's the end of the example problems that you'll need in order to work the exercises in the homework section 6.4 that are coming from section 6.6.